Good morning to all. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss sweetness and its scale of measurement. Sweetness and its scale of measurement. We eat daily, and in our food we take many type of carbohydrates, as for example fructose, sucrose, glucose, lactose, dextrin, and starch. There are many types of carbohydrate, and in our food we take it and we feel sweetness. As for example, fructose, it is sweet. Sucrose, also it is sweet. Glucose, it is well known for sweetness. Lactose, which is found in milk, that is also sweet. Dextrin and starch, all are carbohydrate and all are sweet. Then how we will compare and what are scale of measurement, that I want to discuss. Which one is more sweet and which one is less sweet. Then just order of sweetness. First I will discuss order of sweetness among themselves. That is in a natural carbohydrate. In a natural carbohydrate, sweetness, order of sweetness I will discuss. Fructose, sucrose, glucose, and lactose, dextrin, and starch. Their order now I am telling you. Fructose is at the top in sweetness. Second is sucrose, ordinary sugar, what we are using in house. And third one is glucose. Fourth one is lactose. Fifth one is dextrin. And last is starch. Means among these, fructose sweetness is highest and starch is least. Fructose is the sweetest sugar among cellulose, maltose, and glucose. It is a monosaccharide and also known as fruit sugars, as it is probably found in the naturally in many fruits, and it is measured in relative sweetness. Relative sweetness. So it is compared with someone. What is that? Then relative sweetness is defined as the sweetness in waterless solution in comparison to a standard sucrose solution of the same concentration. Again I am telling you, relative sweetness is defined as the sweetness in waterless solution in comparison to a standard sucrose solution of the same concentration. The relative sweetness for sucrose is set as 1.00. Several factors influence the relative sweetness, such as concentration, temperature, viscosity, etc. Means these are the factors which influence the relative sweetness. What is the unit of sweetness? Just like temperature we measure in degrees centigrade or in degrees Celsius, like that way sweetness is also measured in Brix scale. The Brix scale defines the content of an aqueous solution and is measured in degree Brix, B-R-I-X, degree Brix. In shortcut, it is written degree BIX, capital B, small I, small x, shortcut, degree Bix. 1 degree Bix, just like 1 degree centigrade, this is a 1 degree Bix. 1 degree Bix, that is equal to 1 gram sucrose in every 100 gram of solution. The equivalent, it is equivalent to 1%. 1 gram Brix means 1 gram sucrose in every 100 gram of solution. This is equivalent to 1%. I can tell 1%. Now I will give few examples. Glucose, what is its value? I am telling you. Glucose, which is monosaccharide, its value is 0.74 to 0.8. Its sweetness of glucose is less than sweetness of sucrose. Sucrose is considered as 1.00. All sweetness will be compared with sucrose. Sucrose is considered as reference, means a standard. Then for glucose, which is monosaccharides, its value is 0.74 to 0.8. That is, its sweetness is in between 0.74 to 0.8. And glycine, which is amino acid, its sweetness is 0.6 to 0.86. Means this is also less than sucrose. And xylitol, which is sugar alcohol, its sweetness is 1.02, means more than sucrose. Fructose is sweeter, more soluble and less glucenic than glucose and sucrose. Fructose is sweeter, more soluble and less glucogenic than glucose and sucrose. So it has been recommended as a replacement for these sugars in the diets of diabetic and obese people. Sweetness of fructose is between 150 to 200% more than that of sucrose in term of percentage. Sweetness of fructose is between 150 to 200% more than that of sucrose. In this respect, fructose would be ideal nutritive sweetness because it would give the same texture and sweetness to food as sucrose, but with lesser energy content. Means if you want same type of sweetness as sucrose or glucose, then amount of fructose will be, what you will take, it should be less, so that very less, so that sweetness will be equal. Sucrose and fructose, if you want same sweetness like sucrose or fructose, then fructose you have to take in very less, because it is I told you between 1 to 200% more sweetness. Hence this fructose you have to take in very less quantity, then you will then you will get sweetness like fructose or sucrose, because you will take very less quantity of fructose, hence energy you will get very less. Okay, then this is the important point here, that because it nutritive, you can say nutritive sweetness I am talking about. Sweetness of fructose, I told you it is in percentage between 150 to 200% than that of sucrose. In this respect, fructose would be ideal nutritive sweetener because it would give the same texture and sweetness to food as sucrose, but with lesser energy content. Other examples I am telling you, which may contain, we can say, artificial sweetener also, artificial or synthetic. Actually, only carbohydrates will not give you sweetness. Another, you can say, material, that is artificial, that is called artificial sweetener or synthetic sweetener, that also provides a sweetness. Then now I am giving example for both, that is in a natural way what you are getting carbohydrate, that, and other synthetic or you can say artificial sweetener. I am giving example. As for example, saccharines. Saccharin is artificial sweetener, or sweetening agent. Also you can tell synthetic sweetening agent, and its sweetness is more than 300 times than sucrose. Sucrose is 1.00. Then in comparison to sucrose, this is its thickness is 300 times more. Correct? Means saccharin and sucrose, if you will compare, then saccharin 1 spoon sweetness, saccharin sweetness, if you will compare, then 1 spoon saccharin is sweetness of 1 spoon saccharin is equal to 300 spoons of sucrose. Means sucrose, you will take 300 spoons sucrose, its sweetness is equivalent to, you can say, 1 spoon of saccharin. Correct? Because sucrose considered as its sweetness is considered as 1.0, and saccharin is more than 300 times. Now next I am telling you, that is the mannitol. Its sweetness is 0.5 to 0.7. Maltose, its sweetness is 0.3. Lactose, its sweetness is 0.2, means all are less sweet than sucrose. And aspartame, that is artificial. Aspartame is artificial sweetener. Its sweetness is 200 times more than sucrose, means 200. Its value is 200. And next is glycyrrhizin. Its sweetness is 50. Next is sorbitol. Its thickness is 0.5 to 0.6. And dextrose, its thickness is 0.7. And fructose, its sweetness is more than 1.3, between 1.3 to 1.7. Dextrose is 0.7 and fructose is between 1.3 to 1.7. Like that way, some examples are there which are, you can say, its sweetness is very, very high. Then its example is advantame. Its sweetness is 20,000 more than sucrose. Its value is 20,000. Its sweetness is 20,000 more than sucrose. Neotame, its sweetness is 8,000. This means 8,000 more than sucrose. And sucralose is 600. 600 times more sweeter than sucrose. Sodium saccharin. Actually, saccharin is found in ionic form, salt form. It will give sodium ion plus saccharin ion. Okay, that is in the salt form. And its sweetness is that is called sodium saccharin. Its sweetness is 300 times more than sucrose. And next is esteviol glycosides. Esteviol glycosides. Its sweetness is between 200 to 300. And aspartame, already I told you, it is more than between 180 to 200. Between 180 to 200. And one more artificial sweetening agent is acesulfame potassium. Acesulfame potassium means ACESUL, acesulfame, FAME, acesulfame potassium. Its sweetness is 200 times more than sucrose. And one more this sweetening agent is there, that is actually natural sweetener. Its name is stevia. This is actually also called sweet leaf stevia, and its sweetness is 300 times more than sucrose. And this is low carbohydrate. Actually, it is a carbohydrate in natural way, but low carbohydrate, you will get very less energy, and negligible effect on blood sugar. It has a negligible effect on blood sugar, but it is found in a natural way. Stevia. Okay. Its sweetness is 300 times more than sucrose. Now, other things I want to tell you. Non-nutritive sweetness. Examples of non-nutritive sweetness. Actually, you should know about the artificial or synthetic sweetening agent. The three things are there, you must remember. First, its calorific value is 0. Means if you will eat, you will not get energy. First characteristics of artificial sweetening agent. Its calorific value is 0. Second, it is toxic. Means one should not take it in a more quantity. Sometimes they can take it just to get that sweetness, but if anybody will take regularly in more quantity, then it is a toxic. And third things, it is a non-carbohydrate. Means artificial or synthetic sweetening agents is first, it's a non-carbohydrate. Second, it is toxic. And third, its calorific value is 0. You will not get energy, and its taste is little bitter. After taking, you will not 100% like a natural sugar. You will find just little difference in taste. Now, one more question is asked generally, that you know that carbohydrates are known for sweetness, but all carbohydrates are not sweet. That question is asked whether any carbohydrate is not sweet. Then answer is yes. Some carbohydrates are there which are not sweet in taste. That is actually polysaccharide. Polysaccharides are not sweet in taste. hence also known as non-sugar. But one should not be in confusion. Polysaccharide is not sweet in taste, but after eating, it will provide monosaccharides, means glucose. Example of polysaccharides are common example: starch, cellulose. These are actually high molecular weight carbohydrate. And after eating, actually that is a starch is found in rice, wheat. Then it will be not, you can say, sweet. It will be after eating, you will not find at that time, you will not find, you can say, sweet. But after hydrolysis, when it will go inside the body and in the presence of sufficient quantity of water, it will release, you can say, large number of monosaccharides. Monosaccharides means glucose. Glucose is the examples of monosaccharides. And its formula, chemical formula is C6H10O5 whole n, small n. N means here large number. Then this C6H10O5 whole n, this is actually polysaccharides. Also you can tell starch or cellulose. This plus NH2O. N means again large number of water. Or here what is the N? That number of NH2O is required. Means the number of moles of H2O and number of moles of starch. Starch should be the same. Or you can tell sufficient amount of, in presence of sufficient amount of water. These polysaccharides, example starch and cellulose, that will provide you glucose. And glucose, that will give sufficient quantity, it will provide you energy. It has, you can say, energy, calorific value is high. But you know that glucose, that is harmful for diabetic patient. But it means not that carbohydrate which are not sweet will not provide glucose. That is wrong. It will provide, it has no sweet taste, but it provides glucose after hydrolysis. Okay. Then this is important, that all carbohydrates are not sweet in taste, but after going in body, in presence of water, it provides, means after hydrolysis, it provides glucose. Now I am stopping only here. Thank you.